Join Dive Logic and Suzi Scuba on how diving has always been a dance between human curiosity and the unforgiving physics of the underwater world. For decades, divers relied on analog gauges, dive tables, and a healthy dose of intuition to manage their time beneath the surface. Then came the dive computer, a device that quietly revolutionized the sport by turning complex decompression calculations into real-time, readable data strapped to a diver's wrist. But what was once a groundbreaking tool is now being completely reimagined. The next generation of dive computers is not simply an upgrade, it is a fundamental rethinking of what these devices can do, how they communicate, and how they keep divers safer than ever before. To understand just how significant this shift is, consider where dive computers started. Early models in the 1980s were bulky, limited in function, and prone to errors. They tracked depth and time, ran basic decompression algorithms, and gave divers a rough guide to their no-decompression limits. Over the following decades, improvements came steadily. Better algorithms, color screens, air integration, and wireless connectivity. But even the most advanced dive computers available just 5 years ago were still fundamentally reactive devices. They responded to what a diver was doing, rather than anticipating what a diver might need. That is the core distinction driving the next generation forward. Modern dive computers are becoming proactive, intelligent systems that combine advanced sensor technology, artificial intelligence, and real-time physiological monitoring to give divers an entirely new level of situational awareness. The leap from the previous generation to this one is arguably the biggest the industry has ever seen, and it is happening right now. At the heart of the next generation of dive computers is a shift in how decompression modeling works. Traditional dive computers have always relied on fixed algorithms, mathematical models like the Buhlmann algorithm or the varying permeability model, that calculate nitrogen absorption and off-gassing based on depth and time. These models are effective, but they are built on population averages. They do not account for the individual diver's physiology, fitness level, hydration, fatigue, or the specific conditions of a given dive. Artificial intelligence is changing that. Next-generation dive computers are beginning to incorporate machine learning systems that adapt decompression recommendations based on a diver's personal dive history, biometric data, and real-time physiological signals. Rather than applying a one-size-fits-all model, these systems learn from each dive, refining their understanding of how a particular diver's body responds to pressure changes over time. The result is a decompression profile that is genuinely personalized, reducing the risk of decompression sickness while also potentially allowing more experienced, well-conditioned divers to push their limits more safely. Some manufacturers are already testing systems that integrate data from wearable health monitors worn before and after dives. If a diver enters the water dehydrated, sleep-deprived, or with elevated stress markers, the computer can factor those conditions into its calculations and recommend more conservative ascent profiles. This kind of contextual intelligence was simply not possible with previous generations of hardware, and it represents a profound shift in how the industry thinks about diver safety. Beyond decompression modeling, the next generation of dive computers is integrating a suite of biometric sensors that would have seemed like science fiction just a decade ago. Heart rate monitoring is now becoming standard, but the ambitions of leading manufacturers go far beyond that. Devices currently in development or early release are incorporating blood oxygen saturation monitoring, skin temperature sensors, galvanic skin response measurement, and even early-stage implementations of real-time blood gas analysis. Blood oxygen saturation monitoring is particularly significant for technical divers and those diving with enriched air nitrox or rebreathers. Tracking oxygen partial pressure in the blood in real time gives divers and their computers a far more accurate picture of physiological stress than depth and time alone can provide. When combined with heart rate variability data, these sensors can detect early signs of hypoxia, hyperoxia, or cardiovascular strain before a diver is even consciously aware of a problem. Galvanic skin response, which measures electrical conductance across the skin as a proxy for stress and arousal levels, is another fascinating addition. Elevated stress responses underwater can indicate panic, equipment issues, or physical exertion beyond safe limits. A dive computer that can detect rising stress levels and alert the diver, or even automatically adjust its safety recommendations, adds an entirely new dimension to underwater safety management. The miniaturization of these sensors has been the key enabling technology. Advances in microelectronics and materials science have made it possible to pack an extraordinary amount of sensing capability into a device that still fits comfortably on a diver's wrist or can be integrated into a dive mask. One of the most visually striking developments in next-generation dive computers is the move toward augmented reality heads-up displays. Traditional dive computers require a diver to look away from their environment to check their wrist-mounted device, breaking focus and potentially missing important cues from their surroundings. Augmented reality integration eliminates that problem entirely by projecting critical dive data directly onto the diver's field of view. Several companies are now producing dive masks and full-face masks with integrated heads-up display technology. These systems overlay depth, time, remaining no decompression limits, tank pressure, compass heading, and biometric data onto the diver's visual field in real time. The information is displayed in a way that does not obstruct the natural view, allowing divers to stay fully aware of their environment while simultaneously monitoring all critical parameters. The implications for safety are enormous. A diver navigating a complex wreck or managing a technical decompression dive no longer needs to divide their attention between their surroundings and their instruments. Everything they need is right in front of them, updated continuously, and designed to flag anomalies immediately. Some systems are also beginning to incorporate underwater navigation assistance, using sonar mapping and global positioning system data gathered before the dive to guide divers through planned routes with directional overlays. Beyond safety, augmented reality opens up entirely new possibilities for dive education and guided experiences. Imagine a new diver receiving real-time coaching from an instructor on the surface, with instructional overlays appearing in their field of view as they encounter different marine life or practice new skills. The educational applications alone could transform how the sport trains and develops new divers. The next generation of dive computers is not designed to operate in isolation. Connectivity is a central feature, and the ecosystem of data sharing that surrounds these devices is becoming as important as the hardware itself. Modern dive computers connect seamlessly to smartphones, cloud platforms, and dive community networks, creating a continuous loop of data collection, analysis, and sharing that benefits both individual divers and the broader diving community. After a dive, detailed logs are automatically uploaded to cloud platforms where sophisticated analytics tools break down every aspect of the dive: depth profiles, ascent rates, gas consumption, biometric trends, and decompression compliance. Over time, these logs build a comprehensive picture of a diver's development, fitness, and risk profile. Dive centers and instructors can access this data with a diver's permission, allowing for more informed coaching and personalized training programs. On a larger scale, aggregated and anonymized dive data from thousands of users is being used to refine decompression algorithms, identify environmental patterns, and even contribute to marine research. Some platforms are partnering with oceanographic institutions to collect water temperature, salinity, and visibility data from recreational dives, turning every dive computer into a distributed environmental sensor. The diver becomes not just a beneficiary of the technology, but an active contributor to a global knowledge base. Wireless tank pressure transmitters have also become far more sophisticated, with next-generation systems capable of monitoring multiple tanks simultaneously, tracking gas mixture composition in real time, and predicting remaining dive time based on current consumption rates and planned depth profiles. The integration between the tank, the computer, and the diver's physiological state creates a unified safety system that is far more powerful than any of its individual components. What is emerging from all of these developments is a vision of diving that is fundamentally safer, more personalized, and more connected than anything the sport has known before. The next generation of dive computers is not just a better tool. It is the foundation of an entirely new relationship between the diver and the underwater environment. As battery technology improves, sensors become even smaller, and artificial intelligence models grow more sophisticated. The capabilities of these devices will continue to expand in ways that are difficult to fully predict. What seems certain is that the passive, reactive dive computer of the past is giving way to an active, intelligent companion that understands the diver as an individual, anticipates risks before they materialize, and communicates information in ways that are intuitive and immediate. For recreational divers, this means a safer, more confident experience in the water. For technical divers pushing the boundaries of depth and duration, it means tools that can genuinely match the complexity of their ambitions. And for the sport as a whole, it means a future where the barrier between human capability and underwater exploration continues to shrink, one dive at a time. Catch Dive Logic and Susie on the next episode, and always remember, fins up.